presentation. I just thought it was funny. All right, so just now we were talking about physical capabilities of LoRa. We talked about, about microcontrollers and what makes them cool. So let's look at like how can we make these devices run for so long on a battery. With a lot of networking technologies like Wi-Fi or also cellular, you always need to be connected to the base station. So that means that there's always some power being consumed, making sure that that connection is still in state. What kind of is cool in LoRa is that, at least in the class that we're using, class A, is that it's completely device initiated. So the device has the freedom to send literally whenever it wants. There's no limit. You don't have to say, I'm going to send in 5 minutes, or negotiate with the network and saying, well, my next slot is going to be in X seconds. It's just whenever you want to send something, you just power up your radio, blast something out, and then you go immediately to sleep again. And that's really nice, because if you decide that you only want to send stuff once a day, like a water meter or something, you can just be asleep for the rest of this time, wake up, send. It also means that if you are using this as a kind of what we're using in the greenhouse later today, because we want to see data quickly, if you're going to be sending every 20 seconds, you're gonna be burning through your power budget quite quickly. It's not that it uses less power to send, it's just that there's no communication needed. So whenever you want to send, you can actually send. So a bit of the setup that we have here. So we have a lot of devices. We have 2 gateways in the setup that we're going to have here, but the idea in LoRaWAN is that it doesn't really matter how much gateways you have, you can just add extra ones whenever you need to. And every device is not tied to a single gateway, they just talk to whatever gateway is available. And that's possible because there's no logic on the gateway. So all the data from the gateway is just sent to a network server. In this case, we're using a network server from the Things network, and then gets delivered to an application. So the nice thing is, let's say that you see that you have very spotty connection at a certain area. The only thing you need to do is get a new base station, plug it in, and that's it. Now your network coverage is improved. And that's really nice because, I used to work for a telco back before I joined ARM. And there's a lot of money and time being spent, and actually machine learning applied, in finding the best spots to place a cellular base station. Because you don't want too much overlap, because that's confusing the devices. You want to have a little bit of overlap, because if you go from one cell to another, for example, you're driving in your car, you need to have a handover that's fast enough so your call doesn't get dropped. Plus these things are really expensive, not just the base station itself, but also the site location. So there's a lot of money being spent there. Here, it doesn't really matter. You need more coverage, plus plug in another gateway. And then these devices have a functionality called adaptive data rating, where if they see that the connectivity strength goes up, because, for example, a new gateway was being placed, they automatically start sending faster, so using less power to actually send. Really nice. LoRa operates in the unlicensed spectrum, so that means that everyone can just buy a gateway, put it up. You don't need permission from a government agency. You don't need permission from a telco. It depends a little bit where you are in the world, what frequency you need to use. In the US, 915, in Europe, it's 868. As you can see, Africa doesn't have anything defined yet. I looked it up. It seems to be that 868 megahertz is you're allowed to use that for this kind of purposes. It's a very clean band as well. But if all of a sudden a couple of guys from the government in suits show up and arrest me, then you know why. So we're using a network server called the Things network, and I'm kind of, enthusiastic. Has anyone heard of the Things network? No one. Very interesting. So it's run by a couple of friends of mine, actually. 3 years ago, they figured, well, if everyone can set up a network, and these gateways don't need to be bound to something, they just forward data, then why not use that to build like a decentralized network? So a network where everyone is completely decentralized and open, where everyone who wants to make the network bigger, they just buy a gateway, plug it in, and now everyone in the world can just use that. And that's really cool. If you go to an area, for example, Amsterdam is completely covered with the little soil moisture monitor that we're building. You can just go, you put your device on, and it will just route it through the gateways that they have there and actually get to the internet. I think it's cool because no one owns that infrastructure. We're putting 2 of these gateways now in Nyeri, around here, and it doesn't mean that only people in the university can use it. Literally everyone, it's an open gateway. They can send their data. And kind of what makes this possible is because it's really low data rate anyway. Yeah, I mean, you're not with the 200 devices or something that we're putting out on campus, we're not going to satisfy the whole backhaul of that gateway. It doesn't really matter. So I think that's really cool. It's like it's free and open roaming. I think it's a fantastic initiative. Yeah, so I want to do a little call out. I think if you think that LoRa is cool after these couple of days and you're based in Nyeri, like make this a start of like a Things Network Nyeri community. You know, go place these gateways somewhere high up where they actually cover all of the city and go a little bit with that. So we got the first 2 gateways here, and hopefully there will be a start of an actual open and decentralized Internet of Things network around here, which will be absolutely fantastic. Yeah. All right, so let's go to the building something. You see a really nice gateway here, a blue one. So this is a LoRa base station. You have a lot of them. They come in all kinds of prices. Like the cheapest you can go is get one of these concentrator boards with a Raspberry Pi. That will run you about $150 US, which is not super cheap here, but should be doable. Then the multi conduit that we have is about $400, and then the really big ones like the telco style base stations are $2,000. It doesn't really matter what you pick because underneath it's all the same. The same chips are inside each one of them, so it really depends on what kind of filters do you need. If you're going to deploy a LoRa base station next to a cellular base station, you want to have really nice filters to make sure that you only get LoRa stuff and you're only transmitting on LoRa bandwidth, so you're not interfering with your cellular stuff. Something you don't really need here. So here we just pick a gateway, hang it up, and go with the flow. Then we need some device. So we have the Nucleo board that I showed, and then, we customly designed some hardware for this DSA. So it has the DSA logo on it here on the right top corner. Yeah. You know, you thought, you thought t-shirts were cool. This is even cooler. So yeah, what this has is, it has a LoRa transceiver. So there's the LoRa radio on it, a little battery connector, some storage in case we don't want to send straight away, we want to cache some data. A secure element where you can like store keys, etc., so to make sure that your keys don't leak. We're not using it today, but it could be possible.
I have a question.
Yeah.
What's the difference between the ARM device here and RG?
Ah.
Does it look like the same thing?
It's very similar in the sense that it's both a microcontroller. Yeah, no, it's very similar idea. In general, the ones that we have are a bit more powerful, and they come with a larger software set. So Arduino is, here's how you toggle a couple of pins. And then after that, there's a very wide community of things around it, but they often only run on a single board. I think they're complementary, I think. So yeah, the idea is, when you're going to do this, is that, so they're like a pair, right? So the one on the left has the microcontroller on it, so the brains, and this one only has the transit module. So just take it, and let's just pretend that it actually fits. So you just click it on, and after that it's ready to be used. And then on the side we got a couple of pins. Guys who've been here last year will remember this, where you can actually hook in other stuff. So, for example, I got this here. So basically, going to look like this. So we're going to have a battery. So we got a little battery pack with 3 AA batteries, a soil moisture sensor, and a temperature humidity sensor. So the use case that we have today is the greenhouse monitoring one. Tomorrow we're going to do something with air pollution. So you have the dev board, LoRa shield, and a battery, then a soil moisture sensor, and a temperature and humidity sensor. Because I'm also realizing that getting a general idea of this might take a little while, is we're going to get started using our simulator, which is very new. About half a year ago or something we started working on it, and got publicly released only a week ago. And in there you can do all kinds of like interesting, like doing basic circuitry, for example, like what if I hook up a temperature sensor, what can I do with it? But also you can actually talk to our LoRa network. So you can You can go through almost the whole flow of just hooking up a couple sensors and actually sending it over the network to the internet in the simulator. So once we've done that and you get a good idea of what we're actually doing, we can hook up the actual hardware. The idea is that this hardware actually goes into the field. So if you manage to get to the end of the workshop material, you'll have a device with all the sensors hooked up, sending data to this base station. If that's the case, we got a couple of boxes. Yeah, so we got a couple of like the Tupperware boxes, because they're nice and waterproof. Throw it in there, make sure it's still on, then give it to me, and then I'll make sure that we're going to put that into the field this afternoon. So it's going to be your work. Let's see. Yeah, there's one thing we need to think about. In all my wisdom, or lack of wisdom, I forgot to put headers on here. So you can't put anything here. What you need to do is, so you get like the sensor, there's this thing on the end. Then you take 3 wires, you just jam them into the holes. It's pretty far. And then you plug this one into your dev board. So that's a little extra stuff that we need to be doing. It's documented also in the instructions, but you actually have seen it. Then one more thing that I kind of overlooked was that the polarity of the battery holder is wrong. So don't plug the battery holder straight into this thing. Instead, also plug a couple of wires in and hook it up to the dev board that way. Yeah, if you have any questions about that, come ask me. Please not all at the same time. So if you have a neighbor or something that does know what's going on, please talk to him or her. So that's what worked. And then, yeah. So one more thing, actually. So in my group, in the Dev Evangelism group, we're working on a new project. So like an hour ago, at the beginning of this whole presentation, I was telling about like doing machine learning on the edge. So not on a Raspberry Pi, but actually on a really small microcontroller. So we started this project a couple months ago. It's called MicroTensor. And the idea is that we want to be able to run TensorFlow models on the hardware that you guys all have. So we do that by shrinking down the model, quantizing the model, do some other stuff to do memory optimization. It's just inferencing or prediction. But we can do a couple of interesting stuff like the MNIST dataset and the MNIST model we can actually run on here. We can do Cypher 10, a basic version of that. So if you're interested or you're contemplating about a PhD idea and you want to go work on something really cool, MicroTensor is here. So we're starting with integrating it with our silicon as well. We're just 4 guys at the moment working on it. So if you're looking for a really cool project to work on, it's open source. Go to microtensor.ai and get involved. I think it would be really cool. This is a demo of doing handwritten digit recognition on a microcontroller, very similar to the one that we're using today. So you can draw something on the touchscreen, press the button, and then it runs. It's a multi-layer perceptron running here, telling you the number, which is cool. It's very cool. Yeah, so around the field work, this was the prep that we did yesterday, 10 kilometers of walking, back and forth to the greenhouse to make sure that everything's actually working. It was very fun. Yeah, if you're done with building the device, it's going to look a bit like this. So we have the temperature humidity sensor there, soil moisture there, dev board, little thing here, and a battery holder on the side. It's going to be pretty straightforward, I think. At the end, you're going to see something like this. So we have application data flowing. We have a little dashboard where you can see that. You'll see the analog in value. That's the value of the soil moisture sensor, the humidity sensor, which is humidity, and then the temperature sensor is the temperature sensor. If you see the data flowing like that, it's actually going to an application that Gentao is building. And tomorrow, Saturday, I think there's like the ML part of the field, or the data science part of the field work. So you all get access to the data set that we've been building in the last couple of days. And then you can do something really interesting with that. And with that, thank you. And we're going to do fieldwork stuff. Yay. Now you can clap again. I want a second round of applause. Here we go. All right. Here's the instructions. For the first couple of steps, you don't need a device, hopefully. I'm not sure how fast the internet is here. But I'm going to hand out a couple of devices anyway, and then go do that. We got about an hour and a half, I think. No, a bit less, I'm not sure. I think an hour and a half before lunch, and then hopefully we'll have all the devices assembled. And then after lunch, we'll dive into the field and get our hands dirty, literally.
Right. So, so we have devices. What we'll do is, and you tell me if I'm repeating anything you've already said. We'll be signing them out because we need them back, right? So you want to give them now?
I'll go give them now. Yeah, you just go. You just.
As in, I guess. What about the boat? Do you have the boat?
Yeah, they're in the other box. Okay. Yeah, you just take one and pass them through.
So we'll need the.
Okay. Take one and pass them through. Yeah, one per person.